We are on the section 3.5, page 55. We are going to talk about something called uniform motion. That means like you are driving from here to there, right? On a certain speed. So also some percentage applications. First, let's do the uniform motions. So it means what? Driving things, right? So we have to calculate for driving. What do we usually concerned about? Okay, how far you have to go. That's called what? Distance, right? Then also, what's your speed? Usually we do what? Miles per hour. Then you also wonder how much time you will get you there, right? So three things we are concerning about is what? For driving is one is the distance, one is the speed, one is the time. And they are all related to each other, right? If you drive faster, then you can use less time. Or if you use the same time, same speed, then if you drive faster, you can go further, right? So how does it work? If you have, say, you drive 50 miles per hour, right? For 3 hours, how far you can go? You will be what? 150 miles, right? If you drive 50 miles per hour, so you drive 12 hours, maybe go to Seattle, how far is there? Then you times it, right? That will be 600 miles. So you multiply them, right? Then we are going to figure out things. We will use what? X. So if I say I drive X hours, if I drive 50 miles per hour, how far I can go? You multiply them, same concepts, right? So that will be 50x, right? So what do we have? We have the speed, we call it R, time we use T. Then distance we use D, right? So your distance will be what? Your speed times your time, right? So we call it third formula for you to remember. Means what? Distance equals speed R times time T, right? If we say we are going to drive to San Francisco for 220 miles. So if you drive with your grandma for, 40 miles per hour, she won't let you drive too fast. Then how long it will take you to San Francisco? Forever, right? How do you get that? So you will do 220 divided by 40, that would be what? 5.5 hours, right? Say if you drive 40 miles to Eugene, Oregon, then you still drive the same speed. What do you think? How long it will take you to get there? That will be 400 divided by 40. That would take you 10 hours, right? Then if we want to practice the X, say, okay, I'm going to drive X miles, still with the same speed. What do you think? How long it will take you? See, you use distance divided by your speed. That would be your time, right? So that would be X divided by 40. That's how you do, right? So what we are saying is, if I have the distance and the speed, I should be able to find the time, right? Like here. So my time should be what? My distance divided by my speed, that should be my time, right? Okay, say if you drive to where? Maybe Stockton, 240 miles, okay? If you drive regularly 4 hours, you get there. What do you think your speed? That would be 60 miles per hour, right? That would be 60 miles per hour. How do you get that? So you just do total miles divided by time, right? Say if we drive 180 miles, then take you, say, still 4 hours, then what's your speed? That would be what? 180 divided by 4. That would be 45 miles per hour, right? Then we practice X. So if I say we drive X miles, still it takes us 4 hours, then what's your speed? That would be, because everything is divided by 4. That's how we do, right? So your speed would be what? Your distance divided by the time it takes. So you need to remember those, the relation between the distance, time to travel, and the speed of the travel, right? Okay, so let's see some examples. It says a family from South Lake Tahoe decided to take a road trip, which turned out to be 1,180 miles, right? About 500 miles too long as far as the 2 kids in the back seat were concerned. So, to make things worse, they only average a rate of 50 miles per hour. So, 50 miles per hour. Then they have to suffer through for 1,180 miles. How long they have to suffer, right? So what do you think? That's your distance. That's your speed R. How do you find your time? Time should be what? Here, distance divided by R, right? So you do distance divided by R, which, do your math, that would be 20.6 hours. Remember how to do your division? Divided by 50. So how do you do? Two numbers, not enough, one more, right? 50 can go into 118 3 times, then, oops, not really, 2. Okay, 2 times back, 100, then 18 left, you drop a 0, right? Then 50 can go into 183 times, multiply back, 150 and 30. But you still have to drive that 30 miles. What do? So you put a decimal here, right? Put another 0 after your decimal point. Then drop 0, that's your 6. 6 times 50 is 300, right? So it's 23.6 hours. Okay? We are going to practice some more complicated situation for the third traveling things, okay? On your page 56. So we might have 2 different objects, like airplanes travel on the same direction, or the trains travel different direction, okay? Or we take a bus, travel toward each other, how long it will take. Things like that. let's see how we are going to do that. Okay, so on your page 56, first one, it says a jet traveling at 540 miles per hour overtakes a small light plane traveling at 180 miles per hour that had a 1 hour head start. They both left from the same airport. How many miles are they from the airport when the jet catches the small airplane? So there's an airport, they both take off, right? So one is the big jet. Doesn't look like jet. All right, then another one is a little airplane. So it says the little one 180 miles per hour, big one 540. But the little one started first, okay? And for 1 hour ahead. So for 1 hour, the little airplane is here already traveled 180 miles, right? For 1 hour. Then the large airplane, the big one, start to travel. Then the little one will continue to go, right? Then the jet would be much faster than when the big one overtake the small one. At what distance? That was the question. You know, how far from the airport, if they travel the same direction, you will see the big one overtake the smaller airplane. Sounds super complicated, right? So the question was, how many miles are they from airport? So if for the how many miles, we have three things we are working with: distance and speed and time, right? But we say, how do we set up? We need to identify things needed with one variable. Okay, but the things are, so for big airplane, you have distance, speed, and time. Then little airplane, you have distance, speed, and time. They're all related to each other, right? We have 6 things. But to find out how long usually for the things we don't know, we use what? X. If we use distance as X, then we have to do a lot of divisions, right? That's not too, doesn't sound too good, right? When you have fractions. So when we do the speed, third, we do this way. We have 6 things we need to deal with. Both have distance, rate, and time. So you do like a spreadsheet, Excel, right? So what do? We do the calculation on the top, okay? So we write it this way, RTD. So if we do multiplication, that would be easier, right? So time, rate is what? Miles per hour, time is by the hour, distance is the miles. Then we have situation for each cases you list on the bottom, okay? So you have a big jet, you have a small plane, right? You do this way. Then we have 6 places for the things we need to calculate with. So we don't know how far do they travel, right? Then we don't know how many times actually it will take. But we do know what? The speed of the jet, which is what? 540 miles per hour. How about the small airplane? 180 miles per hour. But we don't know the time. Where do they actually reach the same, distance from the airport? We don't know the distance. We don't know the time. But if you make the distance as x, then you have to do the divide, x, because time is x divided by r, x divided by 540, okay? That would get complicated, okay? So instead of using the distance as x, we don't know any of those, right? So let's just do the time, all right? So if time for big airplane overtake the little one, we say take x hours. Then, because little airplane is 1 hour ahead, then continue to travel, then big airplane to travel. So it will travel another x hour, right? Same time, they will see each other. So here, little airplane 1 hour ahead. So how long it would take them to meet each other? Small airplane would be what? 1 hour ahead, right? Then, how far you will travel for x hour for 540 miles per hour? So distance is what? R times t. R times t would be 540x, right? Then small airplane would be what? R times t would be 180 times x plus 1. Do you write it that way? Something is missing. Don't forget you need a parenthesis, right? Because it's the speed times the whole hour thing. So that's how we identify for the third problem. Everything we needed on the one table, okay? Then second, we write the equation. Then look over the question again. Then you must have something are equivalent, right? When they meet, that means what? They travel the same distance. So they travel the same distance. So you're supposed to have 540x equals what? 180 times x plus 1, right? So do we have a linear equation? Can you solve it? So you distribute, right? 180x plus 180. Then get the variable to one side, right? So that would be 360x equals 180, right? Then divided by 360, so x is what? Half, 0.5 hour, right? Don't forget, what's your x? X is the time. So it takes big airplane half an hour, right? So this is a big plane, big jet. Then small airplane would be what? 0.5 plus 1 will be what? Take 1.5 hours when they kind of see each other, right? Then look back, what was the question? How long it takes, how many miles? Are they from the airport when the jet catches the small airplane? We want to find the distance. So for x hour, how many hours? 0.5 hour. What's the speed of the big airplane? 540. So how far did it travel? R times t, right? So that will be 270 miles for the big airplane. Then, how do you know they are right? 270 miles away. So you check to see if the little one travel as, 270 miles as well, right? So the little airplane is what? 180 miles per hour times 1.5 hours. That would be what? 270 miles. So you check this way. They did travel the same distance from the airport, right? That's how you do. Let's look at another one. So for each kind of a situation you first encounter, we have to at least practice 2-3 examples before you can sink in, okay? Then you do a few yourself. Next one, suppose that 2 trains leave Jackson, Mississippi at the same time. One travels east and the other travels west at a speed that is 6 miles per hour slower. So which one is slower, west or east? The other travel west at a speed is 6 miles per hour slower. So west one is slower. In half hour, the trains are 45 miles apart. Find the speed of each train. Okay, so you and your friend depart from the Jackson, Mississippi at the same time. So you travel what? East. Your friend travel west. Okay? Then this is eastbound, this is westbound. So after half an hour, okay, so after half an hour, so say you check your GPS, they have location, locator or something. Then you find out you are 45 miles apart. Then you wonder how fast each train travel. So you kind of figure out, the speed and how long it will take to get somewhere, right? So we say third problem, we use that table. So for the calculation, you write on the top, right? So you write RTD. For the situation, different cases, you list them out horizontally. So this is what? Your eastbound, this is your westbound, right? So for this question, we say, do we know the speed? We don't. Do we know the time? We don't. But we do know something is what? After half an hour, how far they are apart? How far you guys are apart? 45 miles. 45 miles including westbound and eastbound, right? So for the time and for the speed, we don't know either, right? Oh yeah, we do know. Because how far do they travel? Half hour later. So time is what? Half hour, right? Then now it's easier for us to decide which one to use X. We just use R, right? For X for R. So if you say, okay, eastbound is X, what do you think the westbound should be? We can only use one variable to identify them within all this table, right? West is what? 6 miles per hour slower, so that will be X minus 6, right? Then if we do that, can we do the calculation to find the distance? We learned earlier, we said R times T equals D, right? So X times half X. Then R times T, so it will be X minus 6 times half. That will be the westbound, right? So first step, you do your analysis table. Then second one, you will write your equation. Okay, so you do know you guys are 45 miles apart, total distance from both west and east. So what do you need to do? Become 45? You should add them together, right? So then we write our equation, then we solve it for the linear equation, right? We distribute them, that will be half x minus 3. Half times 6 is 3, right? Then you plus half x equals 45. Half x plus half x is x minus 3 is 45, right? You plus 3, so x is what? 48. 48 of what? Golds, dollars? No, that's your x. You have to refer back. It's the speed for the east. So it's a miles per hour for the eastbound. Then for the westbound, what do you think? 6 miles per hour slower. So you minus 6. That would be what? 42 miles per hour. Right? How do you know you are doing right? How do you check? If you check, say 48 miles per hour for half an hour, so that would be what? 24 miles, right? Then for the west one, 42 miles per hour for half an hour, half of that will be what? Travel 21 miles. So total how many miles for both? 40 miles, 45 miles. That's why they have 45 miles apart, right? Okay. So that would be our third problems. Then next one, we are going to do the percentage problem. Okay, so percentage problem, we can use the same skills like those. Okay, and say, but for the concepts, and how do we calculate the interest? If you owe, say, $1,000 on your credit card, then each year they charge you 15%. Then how much you have to pay the interest? $115,000, that's $200. Okay, so $100, 15%, you have to get what? Pay $15. If we do simple interest, 2 years, that's 1 year. Then 2 years, how much you have to pay? $30, right? So your interest is what? The money you owe, say principal, then times what? Your interest rate, 15%, right? Then that would be $15. Then 2 years times how many years you have. So your calculation should be what? I equals PRT, simple interest. Then P is your principal, right? R is your annual rate. Then T is the years. That's how we calculate your interest. Okay? So, let's see how we can apply it with some kind of problems. So on your page 57, look the first one. Mary received a tax refund of $2,000. She split the refund between a regular saving account in case she needs the money sometimes during the next year, and the rest of money she puts into a certificate of deposit CD, which pays more interest, but she cannot take out the money for a year without paying a penalty. The saving account pays 5% simple interest. The CD pays 7% simple interest. And together, they earn $124 in 1 year. How much was invested in each account? Say my friend Mary, she has $2,000. Then she want to put some money into the saving, then some money into the CD. Then CD earns 7%, saving earns 5%. Why does she just put all the money in the CD to gain 7%? But once you committed to put it into CD, you cannot take out. If you want to earn all the interest, if you take out early, then you pay the penalty, then it's not worth 7% anymore, right? So you put the money into the saving, you can withdraw anytime, but you still earn the interest. So we wonder how much money she actually put in the CD and how much money she put into the saving. Total, at the end of the year, she got $124 of the interest for both, right? We have two situations. We know the rate, right? We know the 1 year, but do we know how much money to put into both? We don't. But we do know total is $124, right? So we can use the same idea as this because we have many situations. Each one has a principal, have a rate, have a year, and have interest. Then have two situations. One is saving, one is CD, right? So we want to identify things we don't know. 1, 2, 3, 4. Okay. So all the calculation things need to calculate, put on the top. We will put what? PRT here, put I here. Because once things multiplied, you better put on the back. Easier to calculate that way. Because those are conditions to get I. Then different situations, cases, you write separately. Because each one all need a calculation, right? So we know the rate for saving is what? 5%. So you write it in decimal. We calculate in decimals. So this 1.07, both are year, 1 year. How much we put in the principal? Do we know? Not really, but we do know total is what? $2,000, right? So we don't know what's in the saving, we just put X. Then what's in the CD? Total $2,000. Then X portion of it put into the saving. So you take away $2,000 X dollar from 2,000 for saving. Then the remainder will be your checking, right? Then what do? Then we use calculation I equals PRT. So you multiply them together. Interest rate is this, right? And this one would be what? 0.7 times 2,000 minus X, right? So first, we write our analysis table. Then second one, we need to write our equation. Something must be equivalent, equal to each other. That would be this guy, $124 total, we say. $124 total interest, including what? Saving and CD, right? So you have to put them together, 0.05x add to what? 0.07 times 2,000 minus x. Total will be 124, right? So we have a linear equation, then we solve it, okay? So this 1.05x, then we distribute 0.07 times 2,000 is 140 minus 0.07x equals 124. Do you remember how to multiply your decimals? You do what? 0.07 times 2,000, right? You lined up at the end, so 0.00014. Then you have to count your decimals. Point, right? Decimal, totally how many? 2 here, 0 here. Total you need what? 2 decimals. So you move here, that would be your decimal point, 140. Then we solve it just like your regular number. 0.05 minus 0.07 is what? 0.02 difference, but negative because this guy is bigger, right? X plus 140 equals 124. Then you minus 140. Then what do we have? Negative 0.0x equals what? 16, right? Then you divide it by 0.02. Then what do you have? X is, how do you do decimal division? 0.02, right? Then 2 places, decimal here 2 places, that's decimal point 00. So your divider would be what? 800. 800 what? Dollars, goats? Take a look. It's the money you put into the saving. That would be dollars in saving. If you have 800 in saving, how much is in the checking CD? What do you think? Total 2,000, right? Then 800 put away for saving. Remaining would be what? 1,200 for saving. That's how you would do. Okay? And how do you know you are doing right? You better check, right? So for saving, $800, right? For 1 year, interest rate is what? 0.05 times 1 year, right? I equals what? PRT. So that would be $40, okay? For CD, it's $1,200. I equals PRT, right? That would be $84 for CD. What do you think? Total, how much she will have? $124. So you check this way. Manageable, right? In class, usually we let you do another one, practice and check on you. But here, let's go over it together. Okay? Next one. After earning his college degree, Wang was able to get a job that he enjoyed, plus he earned enough to save some money each month. When his saving account reaches $10,000, he decided to split the money into 2 accounts. Part of money will go earn 4% simple interest, and the rest in a CD, which we pay 6% simple interest. At the end of the year, the investment earned $520. find the amount of invested at each rate. Okay, so let's do the same thing. We write our analysis table like that, right? So you have PRT equals I, right? You multiply them. Then you have two cases. One is what? 4%, one is 6%, right? Total is $10,000. So we know this rate is what? 0.04, 0.06 for 1 year. Then how much on each one he allocated? Total $10,000, right? So if you say 4% is X, 6% will be what? 10,000 minus X, right? Then what's the interest earned? I equals what? PRT. PRT. So we multiply them 0.04x, right? Then this one we multiply them will be what? 10,000 minus x, right? Then that's our analysis table. Put all the situation there. Then we write the equation. It also says total interest will be what? $520 at the end of the year. So for both. So what do you need to do? You will add them together, right? 10,000 minus x, we should get what? $520. Then next step we will do it is solve it, the linear equation, like here, right? So you distribute, that will be 2 decimal, that will be 600, right? Make sure you know how to multiply your decimals. Okay, plus 0.04x equals 520, right? Then 0.04 minus 0.06 is what? Negative 0.02x, right? Plus 600 equals what? 520. Then we move number to another side. What do we have? 0.02x equals what? Negative 80. Okay? Then we divide by negative 0.02, negative 0.2. Negative, negative become positive. So x is what? You should be able to do that. 80 divided by 0.02 will be 4,000 of what? Dollars. For what? 4% one. Right? Then another one for CD1 will be what? Total $10,000. Then for 6% one, you should have 10,000 minus 4,000. It should be what? 6,000. Right? So that's for that one. Then same time, we do want to check to make sure it's okay, right? We did it right. So what do you think? How do you check? So for $4,000, you earn 4%. So that would be what? $160. Okay? Practice multiplication. Then another one is what? 6,000 times what? 6%. That would be $360. Right? Then total, how much? You add them together will be 520. That's what they say. Total saving, total interest on the $10,000 would be what? $520. That's how you check them. Okay? So on this section, we learn two things, two types of applications. One is dirt, one is a simple interest. I equals PRT. And third is what? Distance equals what? Rate times t. Okay? So at the same time, we are practicing how to use what? The linear equations to solve problems. Okay? You do need to practice to connect and to sink in. So that would be our section 3.5.